Hi everybody. Today we are going to talk about the concept of moles. I'm going to talk about its definition and I prepared a couple of questions about it which will make it for you really simple and pretty much easy. What are moles? A mole is a kind of dozen. As you know, a dozen is 12 things in a dozen. That means, for example, a dozen of donuts would be equivalent to 12 donuts. And a mole is exactly the same, but with different amounts of a number, with different amounts. For example, a mole is equivalent to 602 hexillion in a mole. And what is the meaning of this? This means 602 with 21 zeros, but don't worry. In exams, you are not supposed to all the times write these 21 zeros beside each other, since it for sure, indeed, it makes you to be really confused. You are not supposed to write this all the times. You could be able to write it in a lot of ways. For example, 602 hexillion, and hexillion means 10 to the power of 21. Or 6.02 multiplied by 10 to the power of 23, or in its simplest way, Avogadro's number. 602 hexillion is a gigantic number, but atoms are so tiny that a mole of it is not going to be that much huge. For example, 602 hexillion of jelly beans is going to be really huge, but a mole of an atom is not going to be that huge, in which you are going to understand it a few moments later. A mole of a thing in some cases can be not that huge, as I said a few moments ago. A mole of jelly beans, as I said, is 602 hexillion of jelly beans. A mole of jelly beans would be as big as a planet Earth. Can you imagine? A jelly bean is not something really huge, but a mole of it is going to be equivalent to a planet Earth, which is really gigantic, is really huge. But a mole of sulfur atoms is exactly the same number, 602 hexillion, or 6.02 times 10 to the power of 23 sulfur atoms. But a mole of sulfur atoms would be as big as a pocket. Can you believe that? Therefore, a mole of something is not supposed to be that huge, since atoms are really tiny, which a mole of it is not going to be that huge. So there are some questions about it which will make it really simple in order to understand the concept of moles. How many moles of O2, or let's say oxygen, which is a diatomic element, are needed to combine with 8.4 moles of H2S? So this is the formula. These are the reactants. 2H2S plus 3O2 is going to be, after they have been combined together, it's going to be 2SO2 plus 2H2O. It's really simple. And you're not supposed to know the atomic weight of each of these reactants and the products. No need. So here it says, the thing that we know, it says 8.4 moles of H2S. So in the reactants, you can see H2S, which is 2. So if we are going to convert this into 8.4 moles, it's really easy. It's just a simple calculation, which is related to the concept of math. So in order to get this, we are going to divide the 8.4 by 2, which is going to be equivalent to 4.2. So we converted the 2H2S to 8.4 H2S. So as you know in math, when you are going to multiply one of the numbers in the reactants or the products by a number, you have to multiply both sides by that specific number. So you are going to multiply that 4.2 by oxygen in order to get how many moles of it is needed to combine with 8.4 moles of H2S. In this case, because the mole in the reactant of oxygen is 3, so we are going to multiply 3 by 4.2, which is going to be equivalent to 12.6. So we notice that there's going to be a relationship between H2S and O2. And also you could be able to solve this problem with a simpler way that I like it the most, which is really simpler. That means there are two ways. The second way is that you are going to write the thing that you have, in which is 8.4 moles of H2S. So you are going to, so the thing that we want is to get that 12.6. So we have to eliminate the moles in order to get a number. So as I said before, there's going to be a kind of relationship between the H2S and O2. There's going to be a relationship between 2 moles of H2S and 3 moles of O2, as you can see in the reactants. That's why we are combining it with a shajar. So 8.4 mole of H2S, as it is written in the problem, multiply by the 3 moles of oxygen by the 2 moles of H2S. 2 moles of H2S is the one in the reactant, and also the 3 moles of oxygen is the one in the reactant. So we put the problem on the numerator and the H2S, in which you can see it in the reactant, on the denominator of the equation. So you could be able to eliminate the moles in H2S by the one in the numerator and the one in the denominator. So as you can see, I eliminate them. So only H8.4 multiplied by 3 moles of oxygen divided by 2, which after this concept, the answer is going to be exactly the same, 12.6 moles of oxygen. There are two ways in order to do this. You can choose any of them, no difference. You are going to have the exact same answer. So the second question, in order to understand much better. How many moles of oxygen are needed to react with 7.2 moles of propane? As you know, propane is C3H8, and the formula which is being placed is 1 C3H8 plus 5O2. These are the reactants. They are going to be combined. They are going to react together in order to get 3CO2 plus 4H2O. So it wants 7.2 moles of propane. We are going to do the exact same thing. So now in the reactants, what's the number of moles? It's 1. It's not written, so it's going to be 1. So in order to get the multiplication, so we have to divide the 7.2, the problem, by the original mole of propane in the reactants, which is 1 in this case. So 7.2 divided by 1 is going to be 7.2. So we are going to do the exact same thing by oxygen. That means the amount of the mole that we want in the question, in this case is oxygen, because it says how many moles of oxygen are needed. So we are going to multiply 5 by 7.2, which is going to be equivalent to 36 mole of oxygen. And the second way, as you can see, we notice the relationship between 1 mole of propane and 5 moles of oxygen. So we are going to divide it. So we are going to write the problem, as I said, 7.2 moles of propane multiplied by 5 moles of oxygen divided by 1 mole of propane, which is written in the reactants, in which exactly those moles of propane are going to be eliminated, since one of them is being placed in the numerator and the other one in the denominator. So we are going to divide them, which after it, they are going to be completely eliminated. So the complete answer is going to be 36 moles of oxygen. It's really simple. And the third question, or let's say the last question, it says how many moles of propane or C3H8 are needed in order to make 13.5 moles of CO2. How much O2 will be needed? So first it says how many moles of propane, and now it says how many moles of O2 will be needed. So there are two problems. There is not only one. There are two problems. So we know the problem in which is 13.5 moles of CO2. So as you can see in the products, there are 3 CO2. So there are 3 moles of carbon dioxide. And we have to convert it into 13.5 moles. So after dividing the 13.5 by 3, we are going to get 4.5. So 3 moles of carbon dioxide multiplied by 4.5 is going to be equivalent to 13.5 moles of carbon dioxide. And then, as I said before, in mathematics, when you are going to multiply one of the numbers occurring and existing in the equation by a number, you have to multiply it the exact same number in both sides, in the other side also. So we are going to multiply. As you know, the problems are the propane and the oxygen. So we are going to find the propane and the oxygen which are being placed in the reactants. So we are going to multiply both of them by 4.5, which are going to be equivalent to 4.5 moles of propane and 22.5 moles of oxygen. And in the second way, we can notice the same thing, which there's going to be a relationship between the propane and the carbon dioxide and the oxygen and the carbon dioxide. So after we are going to place both of them, first the thing that we have and the problem in the numerator and the denominator. So the problem, the thing that we have, 13.5 moles of carbon dioxide multiplied by 5 moles of oxygen divided by 3 moles of carbon dioxide, which is going to be equivalent to 22.5 moles of oxygen. If you do the same thing by propane, we are going for sure, indeed, we are going to get 4.5 moles of propane. So we're going to write the same thing, 13.5 moles of carbon dioxide multiply by, in this case, we are going to write 1 mole of propane divided by 3 moles of carbon dioxide, in which is going to be equivalent to 4.5 moles of propane. So that's all for today. Thank you so much. Don't forget to subscribe, like, and share. See you in our next video.